Hello, everybody. Welcome to class this morning. I want to thank you for joining me, whether you're watching live or watching recorded. Thank you for watching. Thank you for being involved and engaged in the learning process. As we get started this morning, I want to just apologize, I think is a good term for it. Because I'll tell you, last week I was kind of in my habits. And I said, this module, the assignments are due on Sunday. I sent you out that weekend reminder. Just in my usual Friday habit, my usual Friday flow. And then I went back and looked, and I was like, oh no, this was a 2-week module. So I mean, I don't know if it's too bad because those of you who went ahead and got it done early, kind of have a week break. And then those of you who didn't get it done on time have an extra week of reprieve here. So the Module 5 assignments are actually due this coming Sunday, the 14th. Remember to check that due date guide in the Begin Here section of Blackboard, because I am fallible. I'm just, I'm human. Make mistakes. Done it before, we'll do it again. So, it kind of is what it is. But, we also covered most or really pretty much all of the material that I wanted to cover about Module 5 in last week's live stream. So if you want to go back and get a refresher on that, please do. Go back and watch that again. But what I wanted to do today was kind of take a little different path since we have this extra time. And I wanted to just write some more code and do some more examples. And I wanted to do a coding challenge today, which is, you can tell that because you can see it here big on the screen. And this actually might be one of those live streams that would be better if it was just recorded. Because then you could pause and do it and then go back and see me do my version. Right? So the way this is kind of going to work is but if you're here with me live today, that's cool. You can just kind of walk through it with me, and maybe you can try it again on your own later. Because ideally, if we were in a seated version of this course, what I would do is I would say, okay, here's this program prompt. Write this program based on the things that we know already. And then in about 45 minutes or so, we'll come back together. I'll write my version. And, along the way, you can ask questions and we can work out issues and things of that nature. Kind of hard to do in this format, though. But if you're watching it recorded, it could be a thing. The way I start these off is I kind of explain the prompt. So once, if you're watching the recording, once I explain the prompt, maybe you want to pause the video, go try it for yourself, then come back to the video, watch me do my example, and code along with that, make changes, see where yours differs from mine. That sort of thing. Because, again, one of the big things about programming is that, we all kind of approach problem solving in a different way. And the way that you look at things or the way that you approach problems might be a little different than me. And so we can both have a program that does the exact same thing that's just been written a little different way. They're equally valid. But we're doing a coding challenge, and we're doing the one called Judging Moose. And I have a different version of this. It's essentially the same, but I change it around a little bit in the Introduction to Programming and Logic class. So if you're in that class, you will be in that class, you've seen me do a different version of this program. But also in that same sort of way, it's kind of helpful to see something done in different languages, like in this example here, from Python to Java, just so you can kind of help make those connotations to what you've known before, like if you've taken the Introduction to Programming and Logic class in CIS 115, where we learn Python, versus kind of what we're doing now with Java. You can kind of see and make those connections to different things. Becomes helpful. So we have this judging moose program here, and we're going to write it, and let's see what our prompt for this program is. Let's see what they want us to do. So in determining the age of a bull moose, the number of tines, the little sharp points, these little jobbies here on our model, the number of tines extending from the main antlers can be used. So an older bull moose tends to have more tines than a younger moose. Here we are. You're learning something about zoology today in addition to programming. An older bull moose has more tines on their antlers than a younger bull moose. However, just counting the number of tines can be misleading, because one of the things that can happen is that moose can break off the tines, like when they're fighting other moose. You've probably watched a nature show where you've seen two animals go at it, where they've kind of decided to choose violence on that day, and it can get incredibly rough, and you have antlers and horns and all sorts of nonsense breaking off, and it's really, it's wild, both literally and figuratively. So when we're describing a bull moose, we use a point system to kind of describe the moose, right? And so here's what we want our program to do, to be able to kind of write a program that will help us do this stuff. So we want our program to do the following. We want to be able to take the input of the number of tines on the left. We want to be able to take the input of the number of tines on the right. We want to take those two values and we want to add them together to determine the point value. And then based on the point value, which is the big thing for this module, right, these conditionals, we want to make a decision, because we said we have this condition, we need to make this decision. It's kind of what we do. So we're taking the number of tines on the left, number of tines on the right, we're going to add them together to get the total number of tines. And then based on that total number of tines, we are going to ask our program to make a decision that will help us out with the moose here. So we want to say if it's an even number, we want to print there's an even number of tines. If there's an odd number, we want to print there's an odd number of tines. In both of these cases, we want to print that along with the number of tines. And if we have some other condition, i.e. 0 tines, or which really that would be what it would be 0 tines, we want to print that it's not a moose. And so really, we say 0 tines. But that's not the only condition in which this could be possible. So before we get to writing something here, let's kind of break this down and look at what we need. So we're going to take two inputs from our user. Tines on the left and tines on the right. So both of these are going to be given to us by our user. We're going to take these two and we're going to add them together to get our total. And so based on that total, we're going to have our condition tree. So our total is going to be our input. And we're going to have some chained conditions here. Even, odd, or else. And our else condition here is interesting because we're looking at a number of tines. And we're basically looking at the impossibility of the number of tines to have on a moose. So really, when we're looking at that, we're looking at something that is less than or equal to 0. So we want to be able to cover all of the numbers here from 0 all the way down to negative infinity, which brings up an interesting point. Because that means that as we're checking these conditions, we're not only checking to see if they're even, but we're checking to see if they're positive. So maybe a smarter thing to do here might be to chain a condition. Or rather nest a condition, I'm sorry. To rather nest a condition instead of chaining these conditions. But this is one way to do it. We could chain these conditions and use these compound conditions to check to see if it's even or positive, or odd or positive. But each time we're making one of these evaluations, we're adding something to our complexity. So if we just checked for positivity once, and then have it check for even or odd based off of that, that's going to be a more efficient bit of code, right? Because each evaluative statement adds to the amount of complexity that we have in our program. So if we're checking to see if something is even and a positive number, and then we're checking to see if something is odd and a positive number, that's 4 evaluations. If we're checking to see if something is positive, and then checking to see whether something is even or odd, that's 3 evaluations. So it's only a slight change in complexity here, but it is a change in complexity. So maybe instead of this, we want to write it like this and take our total input, check it for positive, or we could even say greater than 0. So we have a greater than 0, and then we have a less than or equal to 0 as the else condition here. And then based on that, we can check even or odd. So whereas here we had 5 conditions we were checking, even, positive, odd, positive, else, here we only have 4. And so if it's even, we're going to say it's even, and we're going to print out the number of tines. If it's odd, we're going to say it's odd, and we're going to print out the number of tines. And if it's less than or equal to 0, we are going to say that it's not a moose. Relatively simple program. I've got a way that we can extend this if we have some time in our live stream. Because one of the ways that we could do that as well is add another condition. Just to kind of give like a score based on the number of tines. So if we have time today, we might add that into this program as well. So let's go ahead and get to programming this the way we would like to. Now, if you are watching this recorded, if you're watching this later and you want to try this on your own before you watch my version, this would be the place to pause. This would be the place to pause. To test it out before coming back and watching me complete it. Now, I'm going to tell you, if I were you, I would not take any more than about an hour to try. So if you're struggling and not getting it after about an hour, just go ahead and come back here, watch my demonstration, and program it along with me instead of, just continuing to struggle with it. So we know that we're going to take an input from our user, so that's one of the places that we can start. It's always a good place to start. So I know that I'm going to need to import my scanner. So that I'm going to import java.util.scanner. Because I know I'm taking an input from a user. And from here, I'm going to go ahead and delete this hello world out of the boilerplate that Replit gives me. And we're going to create a new method. Remember here, I'm outside of the main method, right? This confines my main method. I'm still in the class, but I'm starting a new method here. And this will be our method to get an input. Right, so what we'll try to do is we'll try to make this a little simpler, so that we can utilize this sort of modularly. We can use it more than once. So let's make a method, public static void. We'll call this get input, and we'll wrap it with our curly braces. And this is going to be the function that I use to import my scanner object into my program. So we're doing it a little bit differently this time. Or you know what? We don't need to do that. Let's just do this all in one function. Let's run this get input in one function. Let's initialize our scanner here. We'll save that I was kind of planning on doing there for when we get into value functions coming up, because that's more of a value function thing. Let's just use this method to get our input from our user and pass it to some variables. So we will bring our scanner into this function, into this method. So we'll need to add our scanner object here. So scanner in equals new scanner system.in. So now we have our scanner object that'll be listening for our inputs when we get to that point. And we will print a little message to our user. So that's system.out.print enter number of tines on left. So that's good. From here, we'll take this and we'll make a variable left. We'll make an integer variable left tines. And we'll set that equal to in, which is our scanner, dot next int. And so we'll do the exact same thing for the write times. System.out.print, enter number of times on the write, int write times equals n dot next int. So this satisfies kind of that first condition that we were looking at in our brief when it was saying, you know, take the number of left times, take the number of right times from your user. So this is all we want to, this is all we really need to do here in order to satisfy the requirements. So now we have a left times number, we have a right times number. We have this method that is isolated to its purpose, which is to get the input. Right, so now what we want to do is we want to be able to send these numbers out of here and put them in another method that's going to do our calculations for us. So we're going to need to revisit this method after we write our new method so that we can call this, call the method inside of this method when we get to that point. So we're going to have to work backwards just a little bit there, but we'll come back to this. And we'll write our new method. And this will be the one that does our calculations. This will be the one that does our evaluations. So we're going to take our left and right in as an argument, add them together. That'll be our total. And then check those conditions that we looked at when we drew our condition tree just a little while ago. So this will be a public static void calculate times. And we will add, or you know what, I think I want it to be evaluate times. Evaluate times makes it a little better. Evaluate times. And we're going to need a couple of arguments coming in here. And these are going to be the arguments that are coming in here that we get from our get input. So this will be our left. So it's going to be int left and int right. So now I can create my total variable. So int total equals left plus right. And so now I can start evaluating this against those conditions that we made. So the first thing that we said we were going to do is we were going to nest some conditions based on the idea of whether or not the number is greater than 0. Right, so if it's greater than 0, we're going to have it evaluate some nested conditions. If it's less than 0, we're going to have it print out. If it's 0 or less, we're going to have it print out not a moose. Right, so let's start off by saying if total greater than 0. If total is greater than 0, we will do the following. We will say if total modulo 2 equals 0. So remember we talked about the modulo. The modulo gives us the remainder of a division problem. So if 2 goes into a number evenly, which is what we're saying here, then it's going to be even. we will print out system.out.println the number of tines is even. There are, we'll concatenate that with total tines. Just like that. So we will accompany that with its else condition. So we have this if condition here, right? That says if total modulo 2 equals 0. Both of these are inside of that total being greater than 0. So it's evaluating both this if condition and this else condition on the condition that total is greater than 0. So this condition, our if condition here, total modulo 2 equals 0. That covers all of the numbers that are greater than 0, so 1 to infinity, and evenly divisible by 2. So all even numbers from 2 to infinity. So meaning with our else here, our primary if condition here of total greater than 0 also is going to be true. So this is all numbers that are from 1 to infinity that don't match this first condition. So if we say that that first condition is all even numbers from 2 to infinity, well, then this second one is going to be all odd numbers from 1 to infinity. We don't have to worry about writing that out there. Like we could if we wanted to. We could turn this into an else if and write that condition. But when we have an understanding of how our conditions work and what the inverse of our condition is, we can save ourselves a little time. Right? And let me just add a couple little spacey spaces in here, a couple little line breaks to kind of make things a little more clear. Right? Because we need to make it clear that this curly brace and this curly brace belong to this if statement. This one and this one belong here. And this one and this one belong here. So we have both of these nested inside of this. So it's only going to evaluate these conditions based on whether or not this top condition, this outermost condition, is true. And so in this case, we can actually save ourselves a little time here because we already have a line that's mostly what we need. I can copy that, paste that there, change even to odd, and we're good. We've got something that can work here. So now we just need to add our condition that meets the other condition for this if statement. So that's going to go outside of that if statement. So we have that closing curly brace here. So I'm going to want to put that here. And this is going to be that else condition. Else system.out.println not a moose. And so this covers every possible outcome for the purposes of our program here. And so now what we can do is we can go ahead and enter our call for our method, for this evaluate tines method, into our get input method. So we're going to evaluate tines, and we're going to evaluate them against left tines and right tines. And so that will call this method. It'll take the values that our user put in left tines here and right tines here, pass them through as left and right. And so then these values come through, they become left and right, and they take the place of left and right as we go through this method. So this is really the basics of what we need to do here, and we can add some stuff to this. But let's just go ahead and call our getInput function inside of main so it knows to run, and give this a little test. Zoom out for our test here, and we'll click run. So we're told to enter the number of tines on the left. We'll start out by entering a condition that will give us an even number of tines. So we'll say there are 3 on the left and 3 on the right. And that tells us the number of tines is even. There are 6 tines. Perfect. It's exactly what we want here. Right? So let's try this again, and let's try it with an odd number of tines this time. Maybe 6 on the left and 5 on the right. Maybe one broke off. The number of tines is odd. There are 11 tines. Great. Perfect. So let's try our else condition. We'll say there are 0 on the left and 0 on the right. Not a moose. Not a moose. So that's great. That's exactly what we want. That is exactly what we want here. So let's add some other stuff to this. Let's add some other stuff to expand this now that we have the baseline of a proof of concept of a program. So what I want to do here is I think I'd like to add some input validation, which is going to be pretty nice. So what I want to do here is I want to be able to handle this situation. Run. Enter the number of tines on the left. A. Big error. Because it's trying to put a character or a string inside of a container that is set up for an integer, which in Java, big no-no. So what I want to be able to do here is I want to be able to do some data validation, some input validation. So I'm going to add some input validation here. And this is pretty nice, and we can add it to our programs, because it's basically the same type of block of code. That just gives us a bit of error handling. So right here, you see I'm above this int left lines equals n.next int. I'm above it here. And we're going to write a little conditional statement. If not in dot has next int. So we're looking for in.nextInt here, and we can see this is kind of similar. We're using our exclamation point as the not modifier. So essentially what we're going to look at that input that our user puts in, and we're saying essentially if this console, if our scanner object does not have an int, an integer in it, we're going to run a bit of code. And we're going to run string word equals n.next. So since it's not an int, we need to have a right container for it to go into. So we'll put it into a string container here. And then we'll run a system.error.println word is not a whole number. And then we will put a return statement after that. And so this is simple input validation to check to see if a number was entered, right? And I can just take this block of code here, copy it, and move it here to where we're checking the right. So we have it in both places. Now, ideally, what you might want to do here, and it's probably what we would do when we get to value functions, is put the validation in its own function and pass that to that, and then have the result passed back, sort of thing. But since we haven't done value functions yet, we're not to a point where we're ready to do that quite yet. So we're going to check our input validation each individual time. So now what happens? Our program's still going to run. Enter number of times on the left. Somebody messes around, thinks they'll be cute, and enters in something like a C. C is not a whole number. Now this also helps us in situations like if somebody enters in a decimal number. Because obviously you can't have 0.2 of a time or 0.5 of a time. So if it's anything other than an integer in this case, it's going to convert it to a string and print it out to the console and tell our user that it's not a whole number. And, when we add this to other things like our while method or our while loop like we looked at before, we could actually pass this back and let them try again. Well, we haven't looked at the while loop yet. We've looked at recursion. And you could do this with a recursive method, right? For example, I could say, is not a whole number. Get input. Is not a whole number. Try again. Close my scanner. No, leave that open. And then recurse that get input function. And that can help me out there. So if they put in something weird, and is not a whole number, try again, enter the number of times on the left. 3, skips that, moves on to the next thing. So we could do that and add that to our program. So not only are we, and in this version here, actually, the return statement is dead code. It's not getting reached because we're recursing the function before we're reaching that return statement. So now, number of times on the left, you put in something that's not a whole number. You get jumped back up to the top, enter the number of times on the left, 6. Enter the number of times on the right. You enter in something there. You have to start all the way over, right? But everything still works the way we intended it to work. And we're starting to run a little long here, and I think this can be a shorter live stream. So I think as you're doing this, this is a pretty good program. if you want to challenge yourself, if you want to extend yourself to make this program a little better, try putting another condition in this evaluate times that would check to see if the moose is old or young. So on top of what we got here, we've said that a moose that has more tines is older, and a moose that has fewer tines is younger. So what if we added some conditions in here where we check to see, well, if the number of tines is greater than 9, so if it's 10 or more, then it's probably an old moose. If it's less than 10, it's probably a young moose. What if we tried that? That would be an interesting way to extend this program. So I tell you what I'll do. I'll give you a little extra credit if you try that out. Do this program, extend it with those conditions. 10 or greater, it's probably an old moose. Fewer than 10, probably a young moose. Send it to me in an email prior to the due date on Sunday. And I'll give you, what would be fair, 5 points of extra credit on the large coding assignment for Module 5. Pick a number revisited. Might be worth your time. So with that being said, I'm going to go ahead and end the live stream here for today. I will hang out in the chat for just a couple minutes, just in case anybody who is here with me live has any questions. If you're watching this recorded and you have questions, please feel free to email. Thank you for watching, and we'll see you next time.